proceed further, so the basic principle behind the mass balance is that if there is no chemical changes occurring in the plant, or law of conservation of mass will apply to each component, so that component A, for example, in a plant that is producing sugar, if the total quantity of sugar going into the plant is not equal by the total purified sugar that is in the waste liquor, because total amount of sugar that is coming inside the plant as a raw material should be equal by the total number of purified sugar and total amount of sugar which is in waste liquors. Then if there is something loss or something kind of, there is a difference between the values that has been input and output plus waste, because we know that in the food industry or any kind of industry there is never that we will be getting the 100% of the yield, because we are having some kind of known as that the yield of the product. Means if you are making I say that if you are making toned milk, and if you are taking milk raw milk to convert it into toned milk, then there will be a minimum loss of 0.4%. It is never a 100% yield that from 100 liters of milk you are getting 100 liters of toned milk. There will be a 0.5 to 0.4% losses during the cycle. So it is very important to reduce the losses that as much low as possible, because all the resources and all the energy inside the plant or outside the plant is costing them a very large amount of economic value, and also there is some I can say that it is having some social values, because this energy is produced by using the burning fossil fuels. So it is very important that the food and other industries, because it contributes a large amount in the present industry. So everyone should know the importance of this mass balance and energy balance. So you know that if any process is occurring inside a plant, there are some kind of unit operations are going, they are processing anything outside, so it will be the feed or the raw product, or for example in case of raw milk, in the case of dairy milk, dairy plant, or in the case of the post harvest processing, for example ketchup. So ketchup you are getting tomato, okay, tomato you are processing, and they are going as a raw material inside, and we are converting by using some processing techniques that are been going inside the plant, and which will be converting it into the form of product, which can be for example in the case of raw milk, if you say you are making peda, okay, there will be some other materials like sugar ingredients, stabilizer, preservatives, etc. All other ingredients also we have considered, and we are getting peda. And in the case of tomato you are getting the I say ketchup only. So there will be some kind of losses that have been accumulated in the production area. In the case of raw milk, the primary loss will be what? The rinse water, which has been used to clean the surfaces of milk, which contains the lost the SNF and fat molecules. In the case of tomato, there will be peel waste. Then there will be along with the peel waste, we are having the seeds and the other wastage part, which have been packaging losses. There are a lot of losses. So the particular aim of this diagram is the total mass which is coming in and total mass which is going out have been taken in. If the difference has been taken, we will get the accumulation, and if the assumption there is no accumulation in the plant, then there will be mass in mass out will be equal to the F is equal to W plus P, means the finished raw material is equal to waste plus product. It is the basic equation. Then there comes the material balance. So the principle always lies behind the basic law which is governing, basic law of nature which is governing this energy balance or material balance is conservation mass or energy, because we know that mass is never mass and energy cannot be created or destroyed. It can be transferred from one form to another. So mass can be neither created nor destroyed, however its composition can be altered from one another. So rate of mass entering through the system, through the boundary of the system, minus rate of mass exiting through the boundary of the system, and it is equal to the rate of mass accumulation through the boundary of the system. So overall material balance is that mass in, mass out plus accumulation, and the component balance is the what part of this mass will be converted to the, in what sense we are saying. If we are saying that in a plant how much is fat is lost, so we will multiply that, if we are entering with 6% milk for 10,000 quantity, and then we are getting the toned milk of 3% fat having 3.2% fat having 9,800 liters of milk, and other remaining one will be converted into cream or losses. So we need to know the various components and various fats of the, if we are saying in the percent of fat, then their components will be important, because in the raw milk we are having 6% fat, then we will multiply it by 6%, 6 divided by 100 into 10,000 plus the is equal to, which is equal to the total amount of milk which are getting 3 point divided by 100 into 9,800, and the wastage is around, if we want to calculate wastage, you can calculate by considering it as x, and you can calculate the amount of fat that has been lost during this process. Okay, so what the basic concept means, that if we are taking a food sample, it consists of food solids and food liquid. In the case of, we are having the total solids that you consider when we, in the case of I am giving the example of milk. In the milk, the food solids are the milk solids which contain the fat, casein, lactose, casein plus all the other proteins, that whey protein also, and various minerals, ash or minerals. So these components are also known as SNF, and there is the water available, which is around the 80 to 88% depending upon the species of milk. Okay, so mass of product is the mass of water in food and mass of that dry solids. Okay, you can see the matrix diagram that has been shown here. Okay, then we are going to study about the moisture content. So the moisture content expresses the amount of water present in the moist sample. Okay, so there are two bases that are widely used to express the moisture content. So their first term is that, if you are able to see that, the moisture content on dry basis. Okay, we are denoting it as MDB, and similar way, in this similar or the same way, we are on the weight basis, we are denoting it as weight basis. Okay, so basically the formula for converting the, you should remember the formula only, because there is no use of deriving that formula. It will take a lengthier process. So for the calculating the moisture content in dry basis, so we will be converting it into, we will take the moisture content in weight basis divided by 1 minus. So this is the conversion formula we need to only remember, because the questions will be asked in the examination to convert this so we will take one of the examples. So there will be questions where you have to convert the moisture in dry basis or wet basis to interchangeably and vice versa. So 10 kg of product at 75% of weight basis will contain this 7.5 kg of water plus 2.5 kg dry solids. Okay, so on the basis of dry basis, what here we are having moisture content in wet basis, so we need the moisture content in dry basis. Okay, so what was the formula for calculating the moisture content in dry basis? So we will convert it by, so 75% of total water, and for converting that we will need to we need to do that we will take the moisture content on the moisture content on the weight basis. So moisture content on weight basis is 75 upon 1.75 minus 0.75 minus 0.75 minus 1 minus 0.35 multiplied by 100. Okay, so after converting all these things, we will getting 300 times, because on the basis of the dry solids which has been present in that product, it is around 300% high, the moisture content, as it is 300% high as compared to the what is the on the basis of the dry solids which we are getting. Okay, then their moisture conversion convert a moisture content of 85% wet basis to moisture content on dry basis. It is very simple, we are using simply the formula. Okay, the more the moisture content in the food, it will be higher than the 100% when we consider for the calculating on the dry basis. Okay, and also same questions are there, you may solve and you can write in your notebook and solve it. Here is the solution, but you should know how to calculate such questions. Okay, so moisture content weight basis is equal to, it is calculated by the mass of water divided by mass of water plus water of mass of the dry solids. Okay, so it is always the kg of water present in the kg of the product. It is very simple. Also the weight basis formula have been given here. Okay, then there comes the most important and the important questions that are being used. So if we are giving a feed under the rate of the 100 kg per hour, then we are assuming that there is no accumulation inside the unit operation, then there is wastage will be 20 kgs, then how much product will be formed? The basic formula, it will give 80. We know that if product is coming at 100, there is wastage of 20 kg per hour, then what is the a product that we are getting? It will be obvious, it is that 100 minus 20. Okay, you need to use the normal logic only. Then the some complexity of questions have been increased. 10 kg of food at a moisture content of 80% weight basis is dried to 30% weight basis. Calculate the amount of water in it. So the what is the feed which have been given? It is the 10 kg of raw product on the 80% weight basis have been dried to 30% weight basis. So the what is the 10 kg of product will be converted to 2.86 kg of the product. It how we have calculated the product? So 80% of total water means 8 kg of water, and 20% of solids, it will remain constant throughout the cycle. It will remain constant na. So we have removed the 30%, we have removed 50% of the water. So the amount of water which has been left after removing the total water, it is around the it is around okay, 80% of water. And 1 second. So total water content we will be seeing. 1 second, let me take the eraser to remove that. Okay, so now 80% of total water, it is 8 kg and 2 kg of solid which will be remaining constant. Okay, so 30%, if the product which has been formed is around 2.86 kg, which have been equal to the 2.86 kg which is having amount of water, it is around the total solid is around 2 kg. So when we multiply it with 2.86, it comes the 0.86 kg. Okay, so the amount of water removed, it is around the 8.86 kg. So same thing we have seen that, and there are some more questions which we have to solve, and you have to cover up that thing. So let me read the question. The 20 kg of food at a moisture content of 80% weight basis is dried to 50% weight basis. Calculate the amount of water removed. So first we are going to see the how much is the water content. Then how much is the solids? What are the how much amount of solids are present in that? Then we will see how much amount of water have been removed from that particular process. So the amount of water removed, and we will be calculating by that how much amount of product will be formed by seeing this product. So this is the one of the most important aspects, and you can solve it and mention the doubts which you are getting from them. So now let us begin with the energy balance. So in energy balance, the we are concerned with the energy changes and the energy flow in the chemical process. Whenever a chemical reaction takes place, there are some kind of bonds that are present in between the various kinds of ions or molecules that are responsible for the that take up the energy, also they release the energy. And it is the conservation of energy, or the first law of thermodynamics, means the energy balance is always, and it is always based on the conservation of energy and first law of thermodynamics. So the first law of thermodynamics says that accumulation of energy in a system is equal to energy input and energy output. You know that the basic law of thermodynamics is based on the only on the conservation of mass and conservation of energy. The energy coming into a unit operation can be balanced with energy coming out and energy stored. So the energy in is equal to energy out plus energy stored. So we can say that the sigma or the summation of energy coming entering inside the body or any plant or anything, any unit, any equipment, which will be equal to the energy in living with the products, living as waste materials lost to surroundings, or the total energy which has been accumulated or stored. So energy balances are a bit complicated because forms of energy can be interconverted from various, like some of the processes which involves the various compressors, in which the some of the mechanical energy has been converted into the heat energy, but overall quantities must be balanced. And so what are all our types of forms of energy that can be stored, transmitted, or the can be interconverted from one form to another? The first one is the potential energy, which is always, we can say that in the gravitational force, if it is located at a height of h, anything which is having a particular amount of mass, it is equal to mgh. And in the case of kinetic energy, it is always equal to the half mv square, where v denotes the velocity. And the thermal energy, which is supplied or removed in the process in the form of heat. Also the work energy worked by the pump to transport the fluid. And this is the most important type of energy which is been stored by the molecules, and it is due to the vibrational and the various types of characteristics, and it is also known as the internal energy. And this concept has been very much highlighted and very much deeply discussed in the section of first law of thermodynamics, where m, g, v, and you know all these things. And also the energy balance. In the case of energy balance, if there is a mass coming inside the system and there is a mass system is going out, then the heat exchange and what are the work done by the system have been calculated, and what is the energy balance that accounts for the chemical reaction. And the most common is what is the temperature of income or exit of the stream, how much material must be introduced into the entering stream to provide for specific amount of heat transfer. So these two questions must be arised, and this is the illustration, diagrammatic illustration, that how much amount of product is entering, means the how much amount of reactant at temperature T1 is entering, and also B amount of reactant have been entering in the system of having a defined boundary, and what is the temperature and what amount of heat they are releasing when they are converted into the various products. Okay, so energy balancing technique are: the first, the complete mass balance or molar balance, calculate all enthalpy changes, process conditions, standard reference condition for all components as start, input and output. Okay, then see what are the additional enthalpy charges that have been occurring in the given process, and they solve the enthalpy balance equation. Okay, so these all things we will be covering in this lecture. Also we will be solving some kind of numericals in the future and the upcoming lectures. So thank you so much for watching, and hope you like the video.